This conference will now be recorded.
Okay, so today we'll start with some sort of introduction of understanding the some of the terminologies which we use in the data world, and also we'll see that which are the features which we have supported by Databricks. So Databricks is like we have plenty of features uh, which is basically helping us for processing the data at the different level. So let's first understand some of the key terminologies and what are the features which is supported by Databricks, and after that we'll start the some of the demos. Again, uh, we have a premium account, I mean premium license, and then free editions as well. So both the license we have it. Initially, we'll start with free edition, and then last couple of days we'll use the premium one for exploring the premium features as well. Okay, so let's get started. So why we are here? So we have gathered so we can work with the data. That is important. Data is everything now. So what is data? So anything which you have experienced so far, like uh, numbers, images, documents, videos, files, dates, words, string, anything which you see in a computing world, uh, which is data. So data is a collections of fact, values, or measurement that can be recorded, stored, and processed by computers or humans. Right. So what are the types of data? So again, the types of data depends on the depends on the what context you are having. So by structured, we have primarily three types of data: structured, semi-structured, and unstructured. So when you say structured one, then all the RDBMS and all SQL and all which you see no SQL, which you store, that is structured data. Excel sheet is also structured data. Semi-structured means something like XML, YAML, JSON, some log files, CSVs, and all semi-structured. And then unstructured, something like images, videos, emails, PDF, log files. Sometimes log files which is not structured also, random log files. So that is also, these are the types of data by structure. But if you look at the by nature of the content, it can be numeric kind of data, it can be textual data, it can be categorical data. Categorical data means red, blue, green, male, female, Boolean data, date and time data, spatial data like GPS points, maps, multimedia data like images, videos, and all. So yeah, these are the by content, by nature, and then content. So the question is like how you get the data. That is the thing. So there is a two form of the data generation which happens. One is in batch, and another one is streaming. So batch means which is like uh, collected and processed in chunks. For example, let's say you have a nightly backup, so a daily sales report. That is in a batch. You schedule it. And streaming data, which is like clicks, which keeps coming, or something like a number of traffic, sensor data, weather reports, live chats, and all. This is streaming data actually. Now, what are the source of data? So, I mean, plenty. Nowadays, if you look at the big AI and ML, I mean, source of data can be literally anything. But more or less, we have identified some of the source which is the most popular in our domain, like transactional data, something like a sales database or banking system, operational data like web server, uh, app server logs, error logs, traces, and all kind of things. APIs data like weather APIs, social media APIs, payment APIs. Sometimes you do the manual entries also like a surveys and spreadsheet. IoT and sensors is going to boom actually because we are getting into the AI, ML, and robotics, and also it's going to boom. So we are going to get a lot of data from there also. By the way, your mobile is also generating a GPS data. Yeah. So other data like source, like it can be any files. You can get it from the blobs. You can scrap the website also, just like a Google is doing, right? Google is scrapping the websites and then gathering the data. Published data sets. So there are many places where you have a data sets which is being published by the community. Streaming services, yeah, something like a live feeds, events, example Kafka, Kansas, and then events up. So these are some of the popular source of data which you have. So in short, now the data is important. It can be structured, semi-structured, unstructured, numeric, textual, categorical, boolean, date, time, batch, streaming, and source, any sources, right? So now, when you talk about the data world, uh, there is one keyword which you will find a lot of people are discussing about it. That is data lake, right? Now, what is a data lake? So I'll put it in a simple way, like the data which is you have not processed. Okay, it's like a raw data in any format. Okay, it can be CSV, images, JSON, logs, and all, which you have not processed. You have not cleaned up, which you have not done any kind of processing, so that is called raw data. That is the system where you store this data is called data lake. Okay, so something like you can store in the Azure data lake or S3 of AWS, or Databricks also stored all this data kind of thing. So yeah, that's a data lakes. When you use data lakes, usually the first landing place for all data from the different sources before processing, that means ETL and warehousing. So that is called data lake. So data lake is a kind of concept, you can say, you can say category of software where you store the data which is unprocessed. Now you process the data. Then what we call it? This typically known as a ETL, extract, transform, and load, right? So the process of taking the raw data from the data lake and then extract it, clean, restructure, transform, and putting into the storage system for the later use. So that process is called ETL, right? ETL is like a way to clean the data and bring the raw data to structured format. Now, when you do it, so whenever you need to move data from the source system, like um, data lake or maybe some apps, logs, API, sensors, and into the place where you want to analyze it, so you do the ETL on that data. Now, after the ETL, where do you store the data? So that is the place which we call it a data warehouse. Okay, so data warehouse is a, you can say, approach or technology to store the data which is processed and structured one. Okay, so structured data in one big place, a warehouse designed for fast analysis and business reporting. When you do that, so once you complete the ETL process, whatever the output of the ETL, you store in the data warehousing software. Now for this all ETL, you set up a data pipeline, basically, where data pipelines like you set up a phases, phase 1, phase 2, phase 3, like that, and then you clean the data as per the each phases. So set up process that move data from one system to another one, encompassing ETL, data movement, and integrations. Now there is one more keyword which you might be hearing while working with the Databricks, which is like a data mart. So it is a data mart. So data mart basically we use for the department specific data for specific analytics. For example, let's say Zomato is producing the data which is for for booking the foods as per the different region, country, state, district, and all. So like this is like a one specific data you have it. You can also call it a mini warehouse also, data mart, right? So one terminologies which we use is like a data lake house. So remember that there is a one data lake and data lake house. Okay, both are interrelated. Okay, so don't get confused. Data lake house. So nowadays this terminologies are being used a lot. So you have a raw data. Where do you store? You store in the data lake, correct? You store the non-processed data, raw data in data lake. Where do you store the process data? Data warehousing, data warehouse. Now, nowadays we use one terminology which is called a lake house. So lake house, you store process data, no, raw data and process data both. Okay. So a modern architecture that combines the feature of data lakes, the one which we discuss about the raw data, flexible and at a scale, and data warehousing where you have a structured data for the perform data into the unified platform, sometimes is called a lake house. Now, while working with the Databricks, I think lake house will be used a lot. That's where we have to understand the architectures also for the lake house. So I'll discuss more about it in upcoming sessions. Okay, so again, please remember data lake, data warehousing, data lakehouse. Okay, so data analytics, what is that? So basically, it is a practice for the inspecting, querying, visualizing, and exploring the data for finding something which is insightful, maybe for trends or some answer for the business questions. So that process we call it business data analytics, right? So data analytics you perform on the always clean data. That means the data which you have in the warehouse or data lake, data lake house. Remember that. So after the data is available in a usable structured clean form, usually from the warehouse or lake. Now we also use one terminology which is called a business intelligence, right? So you might be hearing lots of tools like Power BI, Tableau, and all, right? Databricks, SQL. So these tools basically is nothing but we call it a business intelligence tools. So what these tools are doing, you can use these tools, business intelligence tool, to create a dashboard or KPIs or visual reports from the clean data, so business users can make decision. Okay, so when you do that, so when you have a data in the warehousing, okay, or data lake house also, after the data engineering and warehousing, BI is for the consuming and visualizing data and not preparing for it, so it's for visualization purpose. Remember. Now there is one very broad keyword which you hear a lot, that is called data science, correct? So data science is basically, you can say, larger umbrella. I would say like everything is coming under the data science. If you look at the image also, you see here computer science, machine learning, mathematics, algorithms, all the business intelligence, analytics, software development, everything you can bring under the data science. So here, um, data science primarily you have a three domain. One is like a business analytics, machine learning, and software development. So what is this? So data science is a field for building models. Now model development is like very popular nowadays. You might be hearing like MLOps process and all, which I'll cover. I'll show the demo also. We'll develop some few dummy models as well. So field of building models, doing statistical analysis, and using machine learning on the data to predict, classify, or discover hidden patterns. That process is called data science. So remember here you have a, what is the objective for data science? You want to build a model, but how you do that? So you perform three things: statistical analysis, machine learnings, and you do the software development to develop a model, and that whole process is called data science. Okay, so when you do that, so basically nowadays everywhere we are doing the same thing actually. After you have a good supply of clean organized data, because remember that for the training models you need a data, and you have a data in the warehouse. So after you have a good supply of clean organized data, data scientists need ready to use data from the engineering and warehousing layers. So this process is called data science. Again, data science has a subset which is called machine learning. So machine learning is a part of data science. Again, machine learning is also part of the artificial intelligence, also AI. So machine learning is a branch of AI that focus on building algorithm and models, enabling computers to learn from the data and make predictions, okay, or decisions without being explicitly programmed for each task. Now machine learning is also very big domain, big things. I will discuss when I'll discuss some of the services of Databricks of for during the machine learning session, so I'll discuss more in detail. Right now, just let's understand that at a high level, these are the terminologies we are using in the world of data processing. Now you must be hearing business analytics also. So what is the purpose of it? So business analytics is to help businesses, companies, organization to make data driven decisions. For example, let's say Zomato, you must be ordering almost every day, right? So from which part of the city the biryani is being ordered more, so that is that kind of information I needed, so I can send it to my restaurant, and then they can prepare the more biryanis in advance, right? Something like that. So this is like a business analytics to help businesses make data driven decisions, identify trends, solve problems, and improve outcome such as profit, efficiencies, and customer satisfaction. For that we do the business analytics. How it works? So basically we collect the business data, for example sales, customers, operations, marketing, and all, analyze the data using some algorithm, statistical analytical methods, visualize the results in terms of chart, dashboard, and reports, and then whatever we get it, we take action, we share, and then take action and build the strategy for our businesses, right? So now there is a keywords you have. One is like a business analytics, second one is a business intelligence, and there's a third one, data analytics. This you've been hearing a lot. What are the primary or fundamental difference between this? So basically, business analytics is often used interchangeably for the VI and data analytics. Okay, so it's like little bit of differences but little bit confusing also. So business analytics, when you say, focus more on exploring data, running analysis, and creating model to guide business choices. That means you do the business analytics, and then outcome of the business analytics is like you have some knowledge on which you can make a strategy for the organization. But business intelligence is nothing but like a kind of creating a reports, dashboard, and stuff like that, which can be historical data or predicting the stuff for the business benefit. And these two together under, it's coming under the data analytics as like a broader field. So you can say business analytics and intelligence is coming under the data analytics. That includes all kind of data, not just a business, but all level of data. For example, predictive, ML, descriptive, and all. So yes, these words are like little confusing, but just get comfortable with it. So if you want to understand in this way, business analytics, main focus to build the insight, prediction, recommendation. The outcome is like a reports, models, action plans. Business intelligence, main focus is to develop a dashboard, monitoring, reporting, and all. And outcome is visualizations and reports. Data analytics, all types of data, method, and questions, and it can be outcome anything actually. Now, one more keyword which is coming very popular, which is called data mesh. Okay, so what is this? So data mesh is becoming popular because of our approach is to store the data not at one place, but at a different places, uh, different region, different data centers, uh, in a decentralized way. So that is the concept. So architectural approach that decentralized data ownership, letting down team treat their data as a one product, that concept we'll call it data mesh. Okay, I think big data is something which you must be knowing definitely, because it's been there from last 10-15 years, right? Hadoop and all, you must be have, I hope you have worked on that also as well. So big data refers to extremely large amount of data, like a bank or something like a sales record of Amazon.com, Flipkart.com, something like that. Extremely large, complex, rapidly growing sets of data that are difficult and impossible to process, store, and analyze using traditional software. For example, RDBMS systems and all and tools. So for that, you need a different software altogether. So that is called big data. So that means the data which cannot be simply uh, you cannot store, you cannot clean, you cannot extract, you cannot query, you cannot analyze using the traditional software easily. Then for that you need a big data. In short, big data is equal to large, fast, and diverse data that requires new tools and skills to make sense of it and unlock its value. Okay, so what are the main characteristics of the big data? How can you identify whether it's a big data or not? So five V's are popular in this domain. First thing, volume, massive amount of data. Second one is velocity. You are generating the data at a very great speed. For example, Facebook post. Millions of post is being generated, millions of images being uploaded within a second, correct? So like that. And variety. So variety of the data like text, images, audios, videos, logs, sensor data, databases, and all. Versatility, the quality, accuracy, and trustworthiness of the data you can identify, and values. You can generate some usefulness of the data in generating business insight and innovation. So all these V's, when you are matching with the data, you can consider that data as a big data. Why does big data matters? It enables organizations to find hidden patterns, correlations, market trends, customer preferences, some predictive analytics, real-time monitoring, developing the models like AI/ML, fraud detection, healthcare analytics, and for better, faster, and data-driven decisions for the organizations. Right. So it's like that. How the big data is being handled. So I think very popular software which you have is like Hadoop, Spark, Databricks. Anyways, we are discussing about it, but yeah, many more softwares are there. Okay, now one more keyword you must be hearing in this domain: data engineering. So what is this? So data engineering basically is like a profession. Okay, it's like a role, uh, a profession or discipline for building system and pipelines to do clean, transform, store data so reliable and usable for others, for analytics and scientists and applications. So this is the stream of engineers work actually. Now there is one thing which has gained attention a lot, that is called data ops. So see here, basically, um, you put it in this way: you collect the data from the different sources, and then you store at, let's say, data lake. Then you filter, extract, process through the data pipelines, and then store at the, let's say, warehouse or data lake house, depends on it. So and then you perform the business analytics, data analytics, and then you train the model, and then develop a model, and then you publish the model so people can use it, release the model, maybe predictions also. So many things is being done in the data world which you'll be doing using Databricks also. So this be automated, everything? Can this be slowly automated? Right, everything should be automated. So what we call it, all the operations which you see here should be automated. So that process is called data ops. So data ops is a set of practice, processes, technologies that automate data management for increasing collaboration, quality, improve quality of the data, and cycle time. Cycle means bringing the speed in analytics and data pipeline operation. So data ops is also is like practices. Okay, AI. I think we are going to have a discussions on this AI again in future. Very important tools. I mean, very important concept, not tool. So What is this? It's a branch for the computer science basically, where you can develop a model. I mean, basically you make the machines to learn. You make the machines to learn from the data and then work on that independently and then keep learning lifetime, something like that. So AI is a branch for computer science that focuses on creating systems and machines that can perform tasks that normally require human intelligence. In summary, a technology that makes computer behave and think in a ways that were once considered to be considered to be human, right? So what we do, whatever we do, that should be done by the machines now, and that process is called AI. Okay, so yeah, uh, definition: AI enables computer to think, learn, and make decisions, and often by mimicking human reasoning, problem solving, and perceptions. What can AI do? So it can recognize your speech, example Siri and Alexa, understand your process language, for example GPT, Google Translate. It can identify objects in images and videos, such as like a face recognitions, play games like a chess, go video games and all, make prediction like stock prices, weather reporting and all, and self-driving cars and all stuff like that. So how does AI work? So by using multiple algorithm which we'll discuss, data, some mathematical model to learn pattern and make choices, often involve machine learnings and deep learnings together. Neural networks also like a human brain. We'll discuss all these things AI topics. Okay, so data science we discuss data governance. So what is this? So now when you are processing lots of data, so the the policies, control, compliance also comes along with it, right? How can we do that? So that has been done through the data governance. What is it? So the policy that control who can access what data, data privacy, data quality, compliance, lineage, and data cataloging, that process is called data governance. When we do that, so throughout the entire process, actually we do that. It start as soon as you start collecting, store data, and especially critical as you move, transform, and share data. Real-time analytics, I think the moment you read it, you understand that we want to analyze the data, build the reports, some insightful information from the real-time data. So yeah, the process of collecting, processing, and analyzing the data instantly or within a seconds of being created or received. The purpose, it can be literally anything. It can be security region, it can be your fraud detection, it can be some monitoring requirement, can be stock prices you want to see on the real time, let's say PE ratios and stuff like that, or some stock different algorithms you have, so you want to immediately to be changed the moment the price for the stocks is changing. So those are the things it can be done through the real time analytics. Streaming analytics, a most important example is like your chat, right? On chat data, chat is like a streaming data, right? Or maybe logs, application logs, or IoT device like a car, the one which is self-driving car, which keeps streaming the data, and you have to analyze the data and immediately you have to decide whether you want to take a break or not, right? Self-driving car. So all this thing is coming under the streaming analytics, a type of real-time analytics specifically focused on continuous stream of data flowing in from sources like sensors, logs, apps, and IoT devices. What is the purpose? Again, to analyze, filter, aggregate, and enrich data on the fly as it streams in, and often at a high volume and velocity. Okay, so when you wants to compare the batch versus real-time streaming analytics, so batch analytics when processed after a delay, maybe hours and days, real-time instant
Hello, Rajesh. I lost you. You're not audible now.
SQL, Hadoop, nightly ETL,
Hello,
Spark.
Raj.
Yeah,
Hello.
yeah.
Sorry, I lost you in between. At the beginning of slide itself, I lost this slide.
Okay. Which slide you lost?
Batch versus real time.
Okay. So here batch analytics, which typically process after certain delays, maybe hours or days, but real time always is almost instantly or maybe within a few seconds. Some of the use cases for the batch is like historical reporting. Some of the use cases for the real time is like live dashboard. Some of the tools also we have for the batch analytics like SQL, Hadoop, Nightly and all, Nightly ETL. Real time, Spark streaming, Kafka, Flink, Kansas and all kind of things we have. Now, there is one more word which you'll be hearing in Databricks, natural language. What is this? So natural language is not like, human language we are talking about. Natural language, typically we call it, let's say if you're a native speaker for Hindi, English or Japanese or whatever it is, then we call it a natural language. But in AI and data and computing world, when a people mention natural language, they usually means natural language processing. Okay. So in AI, data and computing world, we call it NLP, natural language processing. What is that? It's a task where computer try to understand, interpret and generate human language. Now human language can be anything actually. Okay. So natural language processing, in which machine can understand our expression. Maybe we are typing, we are talking, maybe we are moving from the face also. They should read some face expression. So it's like that. Okay, now large language model. I think you must be using daily, right? What are the large language model? So language models are advanced AI models that are trained. Remember, these are the trained one to understand, generate, and manipulate human natural language at scale. Examples, I think some of the ChatGPT, Gemini, Llama, Cloud, all this thing, that. So yeah, these are the large language models. These are the models which are trained on our datas. Datas means our websites, our content, our chats, our images, our videos, our conversations, our face pictures, emotions, expressions, everything they have learned and then now they are helping us actually, right? So LLMs are a type of AIs that learn pattern in language by trained on massive amount of text data, website and conversations. How big? Large. Means they have a billions or maybe trillions of parameter internal setting that help them to predict and generate words and sentences. What they can do? Basically, you know that what they can do. You must be using ChatGPT for sure, right? Write human like a text, like a email, stories, reports, code, answer questions, summarize document, translate languages. They can talk to you, assist with the search, content creation and more, right? So these are the large language. Nowadays there is a one which we call it generative AI. LLM, one of the output is generative AI. Okay. So outputs like generative AI, that means they will generate your text, images, video, audio, whatever it's, that's the generate. So you ask something and they will generate for you, right? So generative AI is a branch of AI only that focus on creating new content such as text, images, audios, videos and code that is originally resembles human made materials. It does this by learning from the large data set and then generating new data with a similar pattern or style. I think we are generating every day. Is generating uh, generative AI. The one thing which will be going to be dangerous is like uh, uh, general intelligence. Right now, ChatGPT can do generative AI, but once it's become a general intelligence, it will become a very dangerous. Again, we need to see that next couple of years. Okay, so now this image, I think, will help us to visualize everything, whatever we discuss, right? So look at this very simple image, and you see here all the data, raw data we collect from the different sources and store at a data lake, raw data. Then we process through the ETL and pipelines, and then we store in the data warehousing. But nowadays also we call it a lake house. Please remember. So Databricks is a lake house. It's become lake house. We'll discuss that. And then from the we take the data from the data warehouse, and then we use data analytics and intelligence for helping the organizations to perform their work, for bet strategies, sales, and whatever it is. Or maybe data science, that is important. Data science means we use the data to train our model, like large language model and generative AI, human, and all other stuff, and through the data analytics platform and so many things. So that is a simple flow, very effective. So remember that. Now the question is why we are discussing this many keywords, correct? Why we are discussing? So basically, why we are discussing, because now you know that what Databricks can do. Okay. So if you want to understand the capability of Databricks, then you should understand all this thing. So here the question is, ETL is can we do the ETL using Databricks? Yes. Can we do the data engineering using Databricks? Data warehousing, data analytics, data business intelligence, data science, data governance, data lake, data analytics platform, data pipeline, data lakehouse, data mart, business intelligence, machine learnings, business analytics, big data, data ops, AI, real-time analytics, streaming analytics, narrow NLP, natural language processing, large language model processing, and database. See here, almost everywhere you see Databricks can do that for you. Correct? Now? So for that, now you need to learn Databricks. Why? Because of so many things you have at Databricks. So business intelligence, typically you can use, I mean, for data marks, partially it's possible. You can use schemas, tables in Lakehouse. Business intelligence, Databricks SQL dashboard. Machine learning's ML flow, I'll teach you. Notebooks, auto ML, model serving. Business analytics, BI dashboard, SQL notebooks, ad hoc analytics. For big data, you remember that Databricks is built on Apache Spark, which can scale to petabytes, right? You can automate everything, use the data and implement data ops. That means you can create a pipelines, workflows, alerting, monitoring, REST API, CI/CD, everything you can, jobs, everything you have at Databricks. You can practice AI. So for that, everything you have, uh, you know, experiment tracking, serving, ML flows, real-time analytics. You have a streaming deltas, DLTs, live dashboard, right? So what I'm trying to say, data bricks is the answer for your complete data operations, which you can think of it. So you can consider this as like a data features of features of Databricks. Make sense, all of you?
Yeah.
Okay, so now coming back to the questions, what is Databricks? Yes, we use Databricks to accomplish tasks essential for processing, storing, analyzing everything end to end. The data that drives critical business functions and decisions, right? So basically, it's a platform. It's not a tool. It's a platform where you can bring the data and you can generate intelligence from the data through Databricks. So yeah, Databricks is unified open analytics platform for building, deploying, sharing, maintaining enterprise data analytics and AI solution which can scale beyond your you know multiple different geographies. You can scale at large scale like a big data and all else also. The Databricks data intelligence platform integrate with the cloud storage, example AWS and Azure, and security in your cloud account, and manages and deploy cloud infrastructure for you. Databricks use generative AI. What is generative AI? So just now you are using ChatGPT, correct? So what you are doing? You are saying, hey, give me this one, correct? And ChatGPT will give it to you. The same way, Databricks, you can ask using generative AI and with the data lake house and to understand the unique semantic of your data and then automatically optimize performance and manage infrastructure to match your business need. So basically you can ask and they'll give it to you. That is also. So you see that here, open data lake where you have storing the data. You can use for the business intelligence, data warehousing, AI data science, ETL real-time analytics and orchestrations. Databricks also uses natural language processing, learns your business language. So you can search and discover data by asking a question in your own word. You ask your question in your word and they will give it to you. They'll understand your question and they'll give it to you. Answers. Natural language assistance helps you write code, troubleshoot errors, and find answer in documentations. So this is a data breaks.
So
Any questions?
Databricks and data intelligence engine both are same.
So basically, Databricks has become a kind of platform where you get every features from the business intelligence to the warehousing to the AI, ML, ETL, real-time analytics, batch analytics, everything you get at one place. Storage, compute, uh, models, registry, serving. You can launch your application from the Databricks also. Everything you have at this now Databricks has contributed also in the open source community. So these are the major product which they have made it open source. So Delta Lake, Delta Sharing, ML Flow, these are the software you can install it separately also. Apache Spark and structured streaming, Redash and Unity catalog, but we will use the cloud one only for everything. Okay, so what you can do with the data bricks? So I think we have couple of slides, approx 50 slides to go. So this will push to the next session and then we'll conclude. Will that be okay?
Okay.
Okay.